So cosecant of x. Where's my full screen? Okay, so cosecant of x is the reciprocal of sine, isn't it? So when we're inputting this, we're going to use 1 over sine of x. So let's figure out the asymptotes of this. This would have asymptotes where the sine is 0. Can somebody tell me where the sine is 0 on the unit circle? At the beginning, which is 0, at 180, which is pi, 2 pi, then it would be 3 pi, and so on. Is that making sense? Anytime on the unit circle, when we are here or here. So that's going to be 0, pi, 2 pi. What's the pattern then, if you had to describe that? Yeah, every integer of pi, right? Okay. So let's go ahead and type that into our graphing calculator a second. And let's go back to, since this is a reciprocal of sine, it has the same period as the sine function. What's the period of sine function? 2 pi, right? So when I'm going to go back to graphing, and I'm going to set my window back from negative 6 pi for my last example. I'm going to type in negative 2 pi for my x-min, 2 pi for my x-max, and then pi halves for my scale. So it looks, oh, what did I not do? I have to do this, 1 over sine x. It looks kind of similar then. What's the difference between that and the secant graph? Yeah, it's actually shifted over pi halves. Now, there's all kinds of relationships between sine and cosine and secant and cosecant. The reason it's shifted over pi halves is because that's how far the sine is shifted from the cosine graph. Okay, same concept. So if I took this graph from before that was centered at 0, 0 and moved it over pi halves this way to the right, I would get the cosecant graph. Alright, so let's make our graph. So I put an xy axis on here. I'll make this 2 and 4, negative 2 and negative 4. And then I'll make each of the big grids a pi. So this would be like pi halves and 3 pi halves. And negative pi halves and negative 3 pi halves. And then I'm going to put some asymptotes on there. Don't forget there's one at 0. There's going to be one at negative integer multiples of pi as well. And so, since there's an asymptote at 0, x equals 0 and x equals pi, I am going to make my u's, so if this is 2, this is 1, have a minimum halfway in between there. What's that? They're not. 2 is here. So I just added a tick mark there. 2 is at this line right here. These are at 1 and -1. Alright, so once again the period of this is 2 pi. The asymptotes we talked about, so they're x equals k times pi, where k is an integer. So that makes the domain all reals except k times pi, again, where k is an integer. It's redundant, but if you've already stated the asymptotes, you could also say all real numbers except the asymptotes and refer to that. And what's the range? So if the range is going bottom to top, it's negative infinity to where? To -1. And then it starts up again at 1 to infinity. Okie dokie. We should do an example of this. You guys feel good about, well, let's do a vertical stretch and a horizontal together. So vertical is not a big deal because it just moves really the maxes and mins. But the horizontal are tricky because you have to move asymptotes. So how about we do y equals 3 times cosecant of 2x. So let's graph that. So this is a vertical stretch of 3, right? We're recording for you. Thank you. And this is a 2x. What does that do to the graph? Yeah, so this right here is a vertical stretch of 3. And this 2x, so what happens then is the new period becomes the old period divided by b. So 2 pi over 2, the new period becomes pi. I just horizontally shrunk this graph by a half. So that's a horizontal shrink. Of 1/2. Okay, so let's put it in our calculators and then we're gonna decide where the new asymptotes are. So to input this in, this is like 3 divided by, because 3 times 1 over sine is like 3 divided by the sine of 2x, if I wanted to input that in my calculator. I'm going to graph it on the same window. Let's see what happens. You should see double the amount of u's. And you guys see how they're no longer at 1. They're stretched up to 3. Okay. So I can fit everything nicely on here. See how here I made these interval of pi. I'm going to make these stretch a little bit so we can fit them on there. So I'll make this like 2 pi right here. I'm not going to quite get off all the way on that one. So let's make every 2 tick marks a pi. So let's figure out where the asymptotes are. List some of the old asymptotes. 0, pi, 2 pi, right? And then we're going to shrink them all by 1/2. So pi, well, first of all, what's 0 times 1/2? 0. So there's still going to be an asymptote at 0. What's pi times 1/2? Pi half. So now there's going to be one instead of at pi over 2. I expanded my graph to make it a bigger scale. Okay, the next one was at 2 pi, but I'm going to cut it in half. So now it would be at pi. Can we see a pattern now? I've got 0 here, here. Where's the next one going to be? 3 pi halves. So once we figure out a pattern, we can go from there. Okay, I'm going to make my scale the same. So this is 2 and this is 4. So isn't 3 halfway in between 2 and 4? So in between those asymptotes, I'm going to make my minimums now at 3 because this was a vertical stretch of 3. And I'm going to do the same on the below the x-axis. So I have plenty of cycles graphed here, but I'm going to just finish off by doing a few in the negative direction. So since this one was above the x-axis, the one to the left would be below.